Thanks for the nice introduction there. Alrighty. And thanks a lot to the Heather and the planning committee. A lot of effort goes into making these things happen, especially when you got the the community plate project. I got married a couple years ago. We did that for our reception, and that was a lot of work and effort, but it was a good thing to do. So, can you guys hear me all right? No? That better? All right. You do kind of feel like a rock star up here when you do this. So I am going to talk to you today about wood plastic composites or the composite decking industry. And why I'm going to talk about that you'll see here relatively quickly. To kind of give you some background on where I come from across the other side of the state in the mighty city of Pullman, Washington, home of the Cougs, and also, more importantly, the Composite Materials and Engineering Center. We have been around in existence since the 40s, mainly focusing on natural fiber composites and testing, evaluating, processing anything related to wood and natural fibers. But in the more recent years, starting in the 90s, I guess it's not that recent, but in the mid-90s, we really started getting into the wood plastic composites, getting more emphasis into the polymer side of the built environment. We have a rather large facility where we can do a lot of commercial and experimental research. We have extrusion lines, which are one of the main processing systems to process plastics. We also have injection molding, compression molding. We have different types of refiners where we can break wood down, we can break plastics down, we can break pretty much anything down. If you ever saw the movie Fargo, the chipper scene kind of thing like that, and we can get rid of some dead bodies pretty quickly. We also have dryers, blenders, pellet mills, densifying, agglomerating materials. And of course, since we're a university system, we have a variety of analytical equipment to do a lot of material characterization. But the other thing that really kind of separates us out is we are an International Code Council certified lab, and so we can actually do third-party testing and processing in our lab without a third-party tester there, so it kind of saves a little bit on your costs if you're a manufacturer that needs to get a product approved. So how you generally work with us, similar to the gentleman there talking about the lab in the Bay Area, we do a lot of fee-for-service for industry. We also do a lot of sponsored research projects, and related to the wood plastic area, we've probably worked with everybody in that entire supply chain in our lab. And so I feel pretty comfortable talking about that with all you guys. So I'm going to talk about composite decking, but it's kind of a all-arching kind of product line. We mainly know it as the Trex decking out there, mixture of wood and plastic. But there's also a lot of other things out there that are surmised from that same kind of operation. The fencing industry is starting to pick up some of that. Anderson Windows and 3M, or Certainteed, I think, did quite a bit with window lineals and door lineals made out of wood plastic composites. And then there's a variety of exterior-based products, and this is where we've really kind of found a niche with these. But the market is pretty much dominated by the decking and the railing, as you see out in a lot of different applications around here. So in the past, these products have really kind of had some issues and got some bad press. Primarily aesthetic. A lot of people were upset with them because of staining and molds. Color fade was another big issue. And so not a lot was structural except for a couple bad ones there kind of thing. But when I look back on it, and I've done court cases and been expert witness related to a lot of these things, never really has it been the plastic's fault. And that's a good thing because we're going to talk about plastics. Hearing the talks this morning, plastics kind of suck, but they also have some pretty good advantages too. But a lot of these things were done with improper applications, improper installation, and so I think the generations of composites that you're seeing now are a lot better off and a lot better refined. The research and development really kind of helped them out, and so we have seen the second and third generation products do a lot better. But like I said, I don't think it's really the plastic's fault, which is a good thing. So why am I talking to you about these and recycled plastics? Well, if you look at the industry, they were some of the early adopters of taking in these waste plastics. And where it really kind of started out with, and I'll get that in a slide or two from here, is the use of wide spec resins. Those are resins that don't quite meet the snuff coming out of the manufacturing facility. And so the wood plastic industry started taking a lot of that. They started taking a lot of post-industrial, post-commercial resins. And the one thing that really allowed us to take a lot of those in was the process was very robust to take a wide spectrum of materials. It wasn't marketed a lot. Trex didn't market at the very beginning that they were recycled plastics, because back in the 90s, recycled kind of imparted that it's not that good of a product, and you're just trying to hide your garbage into something. And so, but now, of course, everybody's jumping on that bandwagon, but it's being used a little bit more. But a lot of that initial work, there was a lot of recycled plastic in those products, but it wasn't really pushed as a market. If you look at the global consumption of polymer in WPCs, it's about 380,000 metric tons of plastic. Of that, 160,000 metric tons is actually recycled. So if you do the math, it's about 44%, which is a pretty big chunk of plastic that we're consuming for this entire industry. And in the States, I think it's probably even a little bit higher than that, because most of the manufacturers here in the States use either 100% recycled plastic in their process or pretty darn close to that. And most of it, as we'll talk about it here, is the polyolefins, the polyethylenes, polypropylenes are the most common ones that you'll see out there. Why don't you see more of it out there? A lot of it comes down to reliable volumes, is just these guys being able to get plastic delivered to their doorsteps. Cost benefit, some of the guys just can't work with it as well. They have issues with it there, along with the processing issues with it sometimes. But you're starting to see a lot of that kind of go away, and the cost of these things is really kind of coming to the front. So if you look at the history with WPC, it started back in the 1980s with American Woodstock, but I don't think they're still around anymore. And they were trying to replace some parts into the auto industry, and they did a flat extruded sheet. But where I really kind of want to focus on is in the 1990s, AERT and Trex, or Mobile, it was Mobile at the time. And you talk to one of those companies and they say they were the first, and the other one says they're the first. And so I don't know who was the first to do this, but basically they were looking, how do I get rid of this plastic waste stream? And Mobile was getting stretch wrap and film wrap being sent back to them. And so they were like, what do we do with this stuff? Do we just throw it away? And they came up with this, or ART, same thing, came up with this idea of putting sawdust or wood flour into these products and making a product out of it. And then the revolution kind of began. Quite a few other people came in line behind them. A lot of them used virgin materials to start out with, but I pretty much, most of the guys that I work with out there right now are predominantly recycled plastics. So that's a good thing. It proposes some interesting problems, but also proposes some nice solutions too. And now in 2000 onward, a lot of these products are a lot more refined. They're a lot better looking. I don't know if you guys ever bought an old Trex deck back in the 90s. It's not a real great looking product, but the stuff they're putting out now is quite nice. And like I said, most of these guys are using predominantly recycled plastics. So I guess it comes down to is like, Karl, why are you talking about this? Well, it comes down to the fact that a lot of times we try to shove square pegs into round holes. We try to find a stream, and I'm sure Dennis talk about this here in the next with dent plastics. A lot of times it's hard to get a plastic, recycled plastic, back to its virgin form and into its virgin application. So you make a milk jug, right? It's pretty simple plastic. It's pretty easy. It's a blow molded film kind of process. Requires a very, very tight processing window. Very, very tight. May seem pretty cheap to you guys, but it's a very tight processing window. Anytime, any type of little disruption in that, boom, you blow that film, you blow that mold, boom, you got reject on the floor. So that has been one of the problems with trying to put recycled plastic back into existing plastic processing platforms. And so what the wood plastic industry has really kind of done is been able to start an entire new processing methodology and a new market stream from this. So when you look at it, and you look at ART and Trex, they were some of the first ones out there. They didn't even start with virgin materials. They started with recycled materials. And that's how I feel as though recycling has to go on a lot of fronts, is that you can't just shove this square peg into that round hole all the time. You got to start organically from the base to change some of those things. And you can see what was really positive about the composite decking market is that it was a lot better performance over wood, and so it got a bigger market share. You know, we were 3% in 1990, 1999, and up to 34% in 2012 of just the decking market. So that's a pretty nice jump. So here's a similar success story. I'm in the wood industry, so I always like to promote the wood industry whenever I can when they're good. And this is a case where they were very good. Do you guys know what that picture is right up there on the left? Yeah, it's a wigwam. That's how we used to get rid of sawdust. Okay? And there was these things all over the West Coast, up into Canada, all throughout here, is they didn't have anything better to do with their sawdust and their planer shavings, so they just burned it. Well, from that, people going, wait a minute, there's some value in that, and that's what started the particle board and medium density fiberboard industry. Is they weren't cutting down trees to make particle board. They were using a waste stream. So it's another great example of not trying to force it back into something, but creating a new industry with it. And right now, the particle board, I mean, that's probably particle board underneath that table right there, more likely. It's everywhere. IKEA is one of the largest consumers of particle board. So it's everywhere. It's a huge, huge industry. And it's a good example of creating a market and not trying to shove these recycled plastics and recycled materials into an existing market application frame. So what's in the product? Just to kind of give you a little background of what's going on there. What's in the mix? It's wood flour, so it's kind of like a coarse whole wheat flour that's in there. So it's finer than the sawdust that you get off of a saw or a planer. Plastics are in it, of course. Additives, mainly the additives that are in there are lubricants to allow it to process a little bit easier. Some antioxidants to prevent some of the breakdown, but not very much in that. They usually come with that. Performance, some people use some fire. I haven't seen anybody use that in forever. UV stabilizers don't work in this process, so they don't use them, but they use a lot of pigments to color the product, and coupling agents. That's the CA on there to help the bond between the wood and the plastic. Other type of fillers that you can use in there is calcium carbonate, talc, limes, those kind of other types of inorganic fillers. The process is usually some type of thermoforming, so we have to melt the plastic to get it in somewhat of a viscous sense. Extrusion is probably the most common way of doing that. That's how you make your decking, your window lineals, a long two-dimensional composite. Injection molding, where you make your cell phone covers and other three-dimensional parts, are done with injection molding. That hasn't been as big of a market for the WPC industry, but everybody says it's going to be somewhere down the road. But we'll wait and see what happens there. The other ones you can do is pressed or compression molded composites there. So the home for recycled plastics really came, like I said, about this robust processing system. So if you look at going into some of the technical detail, is one of the biggest issues with recycling plastics is how these materials flow when you heat them up. And when you're like I said, if you're going to make a bag, a bag for anything, it needs to be a really tight tolerance for that melt flow, that flow characteristics. And so you get something similar to that up in this corner, where you get a very laminar viscous flow, where it flows like water more than a plug flow, which is kind of what wood would do. is kind of flow through that pipe or flow through the die as a plug. That big difference right there allows WPC manufacturers to run a whole host of plastics in their process. And so it becomes this very robust garbage dump of plastic that these guys can use. And so that's where it gets its advantage, and that's where you can take, these guys will take any type of polyethylene in their process, any type. They love bag stock. I mean, that's what Trex has lived on, is bag stock, film stock. They love that stuff. When you get into plastics processing, MFI is very crucial. You can't take those things. You get colors in there that people don't want. The decking industry, they just add a little color to it to darken it up and cap it and cover it up. So it has its advantages. So current processing techniques, so a lot of these guys didn't start out as plastic recyclers right away. They would buy plastic pellets from other folks, or they would have some type of post-industrial scrap that they were processing themselves. But as these guys have grown and developed and matured, a lot of these guys have vertically integrated themselves farther up that recycling food chain and started taking in bales of plastics that they process down, they clean, they have a little bit more control over it. So a lot of these guys are just big recyclers that produce a deck board at the end of it. And then the other thing that's really kind of helped them out is the whole idea of capping. And I don't know if you've bought a deck lately, paid an arm and a leg for a deck lately, but most of the decking that you get for composite lumbers has a cap around it. And that cap does a lot of things. It seals in the product, prevents a lot of the mold and stain issues, but it also kind of covers up what you got underneath there, so you don't have to be as clean and as neat. You can just kind of darken up the color on the inside, put a cap on it, everybody's happy. So what are the issues? So if I talk to my guys that are running these guys, running this stuff every day, they are still concerned with contaminants. There's no ifs, ands, or buts about that. And one of their biggest contaminants is thermoset polymers. It's the polymers that cure with heat, and they don't melt and reprocess. They're the acrylics and the epoxies and those kind of things that get in there in their big chunks, and they don't process down as well, and they just kind of leave more of an aesthetic issue. Consistent, reliable streams are always an issue, going with cost in that case. The other thing is thermal limitations. One of our biggest issues that I wish we could solve, but we really can't, is PET. We'd love to be able to take PET and use it as a decking material, but it processes too high thermally, and it just degrades the wood fiber when you do that. So that's an issue. One of the fixes are, of course, like I said, pigments to kind of give you that color stability. That's like the #1 QC issue with the WPC plant is color. Does it look all right? You buy a piece of furniture, you buy a deck, you don't buy it for its structural performance, you buy it because it looks nice. So, got to make it look nice. And then, of course, the advantage is cost. There's no other advantage out there other than that. It's probably the third the price, sometimes half. I don't know what they're getting it for right now, but it's a lot cheaper than virgin. And then marketing promotion, that's kind of an advantage too. So, with all this gloom and doom, all this kind of stuff, it's good to see some other people doing stuff with this. One of the things that I'm part of right now, or WSU's part of, is a institute called Remade Institute. It's part of a DOE-funded NMMI institute that is all around recycling, refurbishing, and reuse. And so we're going to be tackling a lot of problems with polymers, metals, e-waste, fibers, looking at lower energy consumptions. It's a big project. It's a lot of money, but there's a lot of mouths to feed in this whole big world of recycling and reuse. If you are an industry that does recycle plastic, if you guys could get this and fill out these surveys, we're doing some surveys on what are some of the big issues with recycling plastics. I don't know if Heather will have these slides made available or whoever, but it'd be great if you guys, if you're in the plastics industry, plastics recycling industry, to take this survey. If you guys are interested at all in getting involved with this, please give me a contact or give me an email. I'd be more than happy to work with you on this and get you into the mix with everybody else. All right, hopefully you guys didn't fall asleep. I know it was right after lunch, but hey, Thanks.
What's the survey looking at?
I haven't looked at all of it yet, but it's a lot about, you know, what are your issues, what are your price point breaks, what are your biggest concerns right now, where is your market going, those kind of, you know, industry related commercialization.
What's the timeline for it?
I don't know if there's a timeline, but as soon as you possibly get to it, that'd be great.
The state would be very interested in it.
Okay. I don't know, is there any way to, are you guys publishing this stuff or handing out? Oh, okay. And I will give my permission to distribute this.